Okay, question itself says that we have to find out all the Subarrays and the imbalance numbers will be there. Okay, but yeah, what is imbalance number? That is the question. So the imbalance number of a zero indexed array of length n is defined as, okay, so we have to sort the array. First sort the array, and then after sorting, you have to find for all the indexes except last one. Okay, except last one, and then in the sort, remember that you have sorted the array, and the difference between the next element and the present element should be greater than 1. Okay, so for example, if you have 3 1 4, then after sorting it will be 1 3 4, and here find out all the imbalance number. So check 1, is 1 an imbalance number? Yes, 1 is an imbalance number. So here, yes, it's imbalance number. 3 is 3 imbalance number. After 3, 4 is coming. It's not imbalance number. As no. And then 4, it's the last element. So it will not be an imbalance number anyhow. So after sorting, I found it out that yeah, 3 minus 1 is more than 1. That's why 1 is imbalance number. Okay. And then, so I think we know, now we know how to find imbalance number. So the difference from the next element and present element should be more than 1. Okay. So sorted array. Okay. Given the zero index integer array nouns, return the sum of imbalance numbers of all its subarrays. Imbalance numbers of a subarray and sum of all imbalance. Okay. So I have to find out the sum of all the imbalance numbers in all its subarrays. So now you know, like, you have to find out all the subarrays. If you go trivially, then what you will do? You will find out all the subarrays of the array, and after finding out all the subarrays, in each of the subarray, you have to find out the count of imbalance number, and those counts you have to sum finally, right? So again, finding so many subarrays can be of high time complexity. Let's see the constants. So yeah, it's 1000. Okay, length is 1000 and numbers will also be lesser. Okay, that's good. And then okay, so trivially, if I have just three elements, like 314 is the array. If 314 is an array, then for 314, let's find out all the subarrays. So 3 1 is the subarray, then 1 4 is the subarray. And again, why am I avoiding subarray of length 1? Because any subarray of length 1 will not have any imbalance number, because we have to avoid the last element, right? So if 3 is the subarray, a subarray is only having 3. So 3 can never be imbalance number. So not imbalance. So any subarray of just one element will not have any imbalance. So okay. So 3 1 is one subarray, 1 4 is another subarray where imbalance number can be found. Then 3 1 4 is the finally. So does 3 1 have an imbalance number? Yes. And how many imbalance numbers are there? 3 is the okay. I don't think it's having imbalance number, because 3 will be the last element. Okay, but 1 can be imbalance number. Okay, so the count of imbalance numbers is 1, because 1 3, again 3 minus 1. Okay, again for 1 4, 4 cannot be imbalance number. It will be the last element in the sorted format. The sorted format is, okay, let's find out sorted format. It's 1 3, and here It's 1 4 again, yeah. And here the imbalance number is just 1. So just reverse, okay? So, and then 4 3 1 4. The sorted will be 1 3 4, and here the imbalance numbers count is 1. So overall, the sum will be uh, the overall answer will should be 3, right? Not imbalance. So here the answer will be 1 plus 1 plus 1 is equal to 3. Okay. But yeah, let's find out the time complexity. Yeah. So the time complexity will be, first thing is to find all the subarrays, and to find the subarrays, I think the time complexity will be, uh, since the number of subarrays will be exponential, it will be 2 to the power, uh, like include 2 3, not include 3. So for any every element it will be uh, two possibilities. So finding subarrays will be of this to the power n. Okay, the number of subarrays will be something like this if I include all the subarrays of one element as well. Okay, but yeah, so the time complexity will be, okay, order of 2 to the power n. But and for finding the count, it will be just be order of n. Overall, AC will be order of n into 2 to the power. Okay, let's. There's no. Yes. Uh, but yeah, this, I think this is not a good idea, because 2 to the power n is going to be like 2 to the power 1000. It's going to huge, and this is not a good time complexity. So let's think of some other approach. So for now, what we were doing is we were finding out all the subarrays, and we were finding out the number of the count of imbalance numbers. So now what we will do is I'll consider an element as imbalance number, and then I'll find out all the possible subarrays. Okay. So before that, let's talk about duplicates. So since I've written, so okay, so let's consider something like this 3 1, because duplicates will be there. You can see in the example also. Okay, so I'm considering this for better illustration, and so once we will sort this array, so how to find the imbalance number? We have to sort them and sort the elements, and then we have to find consecutive elements if the difference is less more than one. Yeah. So if while sort the array which are having duplicates, then what we will be considering is they are preserving the order. So I have written the indexes of all the elements. So here is the value and here is the index. Okay. Okay. So one sort, after sorting we will have one. So sorting will be done on the value primarily, but the next sorting way will be index. So yeah, this I'm considering it because like in most of the sorting algorithms which we use, they preserve the indexes. So yeah, we are just assuming it. I don't think this is this assumption will not make any difference, because yeah, it's not given over there. But okay, let's proceed with this assumption that if found duplicates, then we are preserving the indexes. Okay, so now we were talking about the method where for any element when it is a sub imbalance number, then we have to find out all the possible subarrays. We will be finding out the count of subarrays. For example, if I have 2, 3, 1, 4, okay, consider 2 as a imbalance number. If 2 is imbalance number, then find out all the subarrays. 2, 3, can it be in this subarray is 2 an imbalance? I don't think, because 3 minus 2 is just 1. So none. And you cannot go before 2. And 2 itself cannot be have imbalance number as 2, as 2 will be the last element. And if 3 is balance, then 2, 3 will be the last element if 2, 3 is the subarray. So 2, 3 cannot be, and 3, 1, yeah, again 3 after 3 there is 1, and 1 is smaller, 3 is last element, it cannot be imbalanced. 3, 1, 4, again after 3 the 4 is coming, it cannot be imbalanced, so none. And then if 1 is imbalanced, then I have to find out all the subarrays. For 1, 3, 1, yeah, 3, 1 will be one way. Then 2, 3, 1, no, 2, 3, 1 cannot be, because yeah, after 1, 2 is coming, 2 minus 1, 1, okay, that is less, not more than 1. Then 1, 4, yeah, 1, 4 will be there. And again, I think 1 I am missing, that is 3, 1, 4. Yeah, here again after 1, 3 is coming, 3 after 3, 4 is coming. So here 1 will be imbalance number. 3 will not be imbalance number, but yeah, 1 will be imbalance number. And if I'm making 4 is imbalance, then I think none. Okay. And same way. So now to find out for all the subarrays for any number to be imbalanced, what I'll do is I'll go to the left and I'll go to the right. And what I'll do, I'll check if any number greater than that element is having value like more than like value plus 1 or not. Like if element is, if array I is okay, if array I is something like 2, then it has the next element should be 4 or 5 or 6, something like that. It cannot be 3 and it cannot be 2 as well after 2. So yeah, so I have to find out 9 plus 1, 9 j less than greater than, yeah, so that I have to find out. And I have to find out it in the right and left as well. And I have to make sure that there is no number which is coming and hindering the subarray. Because if uh, like for example, if I have 3, 1, 3, 4, okay. So if I go to the left 1, I can include 1 as well, because 1 is not just uh, more than and equal to 4. But yeah, okay, it's not a good idea. So yeah, 1 is not more than or equal to 2, but 1 can be included, but 3 cannot be included. So 3, obviously, if I have, even if I have 4 of in this subarray, so if this is subarray, then anyway, if I'll sort it, then after 2, anyhow I have to keep 3, right? So I have to avoid those elements which are hindering to hindering this value, like this is 2, and this I have to avoid any number which is hindering 2 to become imbalanced number. So 3 is hindering 2 to become imbalanced number. So I have to avoid 3. So to avoid 3, I'll just consider Subarray till here. I'll not consider 3. So to make 2 a imbalanced number, I'll travel to the left and I'll travel to the value where I'll find any number which is hindering 2 to become imbalanced number. So I'll stop there. And in the right as well, I'll do the same. I'll check if any number which is hindering, and I'll stop there. So for better illustration, let's come here. So let's suppose we do not have any duplicate for now, and I have to make 3 as imbalance number. So to make 3 as imbalance number, I'll travel to the left and I'll check 3. I can include in the subarray to make 3 as imbalance number. Again, 3 will not be imbalance number because without 7 or without 6, without 8, because after 3, any element should be there which are whose value is more than 3 plus 1, that is 4. Then only that is going to be possible, right? So 5, 6, 7, 8, any value should be there to make 3 as imbalanced number. So after 3, 5, 6, 7, anything can come. So okay, let's travel to the left. So 2 is there. I can consider 2 in the subarray. No hindrance. But again, 2 is not contributing as well. Even it is it is not making any hindrance, but it is not contributing as well. 7 is not making hindrance and it is contributing as well, because 7 minus 3 is 4, and which is more than 1, right? 2 minus 3 is minus 1, so anyhow it is not contributing. And 4 minus 3 is 1, and it's hindering because after 3, 4 is coming, and the difference is becoming 1. It's not more than 1. So 4 is hindrance, so I'll stop at 4. And okay, similarly I'll move to the right and I'll check 1 is not contributing, but it is not hindering as well. 6 is contributing, but it's also not hindering. And 8 is 8 can contribute, but here it will not contribute. Why it will not contribute? The reason is 6 is already contributing, and if you have to select 8 in the subarray, 6 will already be selected, so 8 cannot contribute, but it will not hinder as well. So we can keep 8 in the subarray. And 4 is going to hinder, so I'll stop here. So how many combinations of subarray is possible here? So move to the left. The possibilities are 7, 2, and then okay, so first I have to choose the contributing element. So if I choose 7 as contributing element, then how many subarrays are possible with 3? So the possibilities are these 3 I have to anyhow I have to keep them, okay, but here I can have the possibilities. So here I'll include 1, not include 1. 6 I can include 6 or not include 6. 8 I can include or not include. But so the possibility is 1, 2, 3, 4. So there are 4 possibilities if 7 is contributing. If 7 is contributing, there are 4 possibilities. As you can see, I can have arrays 7, 2, 3 is fixed, and then I can have 7, 2, 3, 1, then I can have 7, 2, 3, 1, then I can have 7, 2, 3, 1, 6, and then like since 7 is contributing, I can move to the right. Like I have to keep 3 as well, because 3 should be imbalanced number, so 3 will be there. But in the right, I can move till this hindrance number, before this hindrance number, that is 1, I can keep 6, and then again the last subarray, that is 7, 2, 3, 1, 6, 8. Yeah. So these are 1, 2, 3, 4, 5. I think here how many possibilities are there? 1, 2, 3, 4. 4 possibilities are there. I think I have duplicated one. So let's, yeah. So 4 possibilities are there if 7 is contributing. And if 6 is contributing, then how many possibilities are there? So again, if there would have been some other values after 7 as well, like if I have some value as here the value is, let's color it something as green, okay, and here the value is, let's suppose 5. Okay. 5 will also be not contributing, but to make 7 as contributing, I have to include 5 or not include 5. So again, the count will be double of 8. So since 4 was the count of Subarrays, now 8 will be the count of Subarrays, including 5 or not including 5, right? So the same way. So let's, okay. And again, if 6 is contributing, then I have to make sure that I do not repeat the same thing, because 6 has been included in with 7. So I'll not include those things where 7 was included for 6. So to avoid that, like I have to count all the elements which are after 6, because anyhow, okay, these values will always be there with 6 to make 6 as contributing. So this value will always be there, and these values between right next and R, these values will be there or not. So these are okay, the same thing. Okay, let's copy it completely. And again, this is contribute. So same thing for right as well. So I'll moving in the right direction, and I'll checking if there is any hindering element. So once I find any hindering element will be equal to num psi, or it will be just 1 greater than num psi. So there I'll just stop. Okay. And once hindering element is found for both the side, and the boundary is found subsequently, like the same way. And after finding all the boundary, I'll find the count in the right possible, all the possibilities in the right. Okay, so the answer will be with the contribution of left and to the right. So if I'm assuming that I'm contributing from the left. So if I'm contributing from the left, all the right elements are considered. So as you can see, if if the left element is contributing, then all the right will be considered. So capital R minus I. And if the contributes, and at the same time, I'm also considering the left remaining element which can be optional. So here this 5 is optional, right? So this is also considered, and this whole will also be considered to make a count. Okay, so this will be making in the count, and this will be making in the count, not for it, just for the difference. I'm keeping it 5, just this 5. Sorry, it's 5, and here, yeah, this thing. So this will be in the contribution. This will be in the option if the left element is contributing. Again, if right element is contributing, then what I'll do is If right element is contributing, then I minus L next. That means if right element is contributing, I minus L next. Okay, that means this I'll be including these things, and then what I'll be including is, then I'll be including R minus R next. That is these things. These are already included. Yeah, these are already included with the 7, because if these are included, then okay, then if with L next only, when I was having R next as well, in that case, you can see that in that case we were going with this and then all these values. Okay, so let's see if this is making the answer. Next, okay. Contribute, and then all the next elements have to make it as contribute. Right count. Only next has to be made as contribute. So the contributing element is so I while left element was contribute, then when left element was contributing, then all the values in the left of it was multiplied, and then this elements was multiplied. This was mandatory, and if right is there, then these are mandatory, and this can be multiplied and this can be multiplied. But again, here when L next was given, then these were already included. Sorry, these were not included. Sorry, these were not included, but these were already included. Okay, these, since these were mandatory, so these were not included when L next was contributing, or L contribute was or left when left element was contributing, then this part was already mandatory. So this is not included, but these are included. Why these are included? Because these were not mandatory. So while multiplying, you can see that when I was multiplying for the earlier, then I was having left contribute minus L. So L left contribute minus L means this part. But this part was not included in the left contribute because this was already mandatory. But for right contribute, these all should be included. But this is already included while calculating left next. So I will not include it. I'll just include this part, right? This will be considered in the left contribute only, okay? Because if I include it, then things will be repeated, Subarrays will be repeated, and that will not be a correct answer. So that's why I have removed L minus L contribute, and I've sorry, L contribute minus L. Yeah, so the area between L and L contribute. So now it's just I minus L contribute, and for R it's like all the elements after R contribute. So again, all the possibilities are calculated for right contribution and left contribution. Okay, so again, finally it is accepted. So I think